Hello world, it's Rahul. Welcome back guys to deep learning tutorial. So guys, today we are going to discuss about core algorithm behind how neural networks learn, including both forward propagation and back propagation. First we will do an intuitive walkthrough for what the algorithm is actually doing, and then we want to dive into mathematics and the calculus underlying all this. So guys, we will be discussing basics about loss functions, cost functions and optimizers as well, just for the heads up. Let's start with neural network first. So guys, in my last video, I have shown what is the basic structure of neural network, where it was getting different incoming signals multiplied by some weights, and then a bias term was adding to it before applying activation function to it. And we have also understood what type of different activation functions we have. So let's quickly jump into how can we train a neural network. So if you can see on the screen, we have this data set where we are having two feature column, that is x1 as age and x2 as BMI, and one target column, that is y as diabetic. So by seeing on this data, we have to predict whether a person is a diabetic or not based on feature column x1 and x2. So let's take this particular example and see how can we train our neural network and predict the correct output. Let's draw a neural network structure. So these are my input signal x1 and x2, and this will be passed to a hidden layer by multiplying each feature with some weight term, and then summation of all these will be added with the bias term before passing it to an activation function. Let's first understand bias before moving ahead. So in neural network, bias is just an additional parameter which is used to adjust the output with the weighted sum of input to the neuron. Moreover, bias value allows you to shift the activation function to either right or left. In simpler words, if my y is equal to mx plus c is an equation of straight line, then c is a constant value of bias. So here number of features are 2, number of observations are 3, number of hidden layer is 1, and number of layers are 3 with one output unit. So guys, we will put all these in a matrix form, as solving neural network problem by just simply multiplying and adding will create a huge mess if you are new to this. Okay, so input matrix will look like as shown on the screen. So here first column is x1 and second column is for x2. Let's add a constant bias term as well, which will act as x0, and let it be 1 for each row. So our new matrix will be like this. Now let's have a look into weight matrix as well before actually solving the problem. So we will initiate two weight matrix, w1 and w2. So here w1 will be the weight between input layer and hidden layer, and w2 will be weight between hidden layer and output layer. So guys, let's randomly put some value to the weight matrix between 0 and 1, so that we can solve the problem and train our neural network. Before moving ahead, let me tell you that we require 3 steps to train our neural network, and that is weight initialization, then forward propagation, and then back propagation. So here we already have input matrix and we have initiated weight matrix as well. Now we only have to iterate through the forward propagation and back propagation, but question is, how can we do that? So guys, to understand what does forward propagation means, let me tell you that whatever input signals we get in a particular neuron, we multiply each features with some randomly initiated weight value, and then add a biased value to a summation of all incoming signal multiplied by weight to that particular neuron, and then pass that to next layer, and this traversing from the input to the output layers. So this process is known as forward propagation. So as I have told you, now we will multiply input feature matrix with weight matrix. Guys, for simplicity, let's only consider one row of input signal. So I have an input of 1, 10 and 15. Let's multiply these input with weight matrix as shown on the screen. So now new matrix will be formed as shown on the screen. Now we will pass this matrix to activation function. Let's consider sigmoid activation function for ease of our calculation. So formula for sigmoid function is 1 divided by 1 plus e to the power minus c. And here z is nothing but the matrix we got just now. Let's fill z value for each row, and now we have this output signal which will work as input to the output layer. So again, we will multiply the weight matrix to the output matrix and apply activation function to this incoming signal as we did earlier. So here is our final output value. We can consider this matrix as y hat matrix. So guys, y hat is a predicted value, and if you compare this value with actual y value, which we were considering as our target value, then you will realize that there is a huge difference in output, or we can say that output is not correct. So now we will find out the loss function, which is nothing but the difference of actual y value and predicted y value. So formula for loss function is y minus y hat whole square. And here we are taking whole square so that output will always be positive for any negative or positive value. Once we find out the predicted y hat value and compared with actual y value, we will try to minimize the difference as much as we can so that our predicted y value will be the same as actual y value. But question is, how can we reduce this loss? So answer for this question is, we backpropagate the output value by updating the weight such that this loss value goes on decreasing, and for doing so, we have so many optimizer functions with us. One of the most common optimizer function is gradient descent, which updates the weights by an amount of proportional to the negative of the gradient and tries to reduce the loss function. So in simpler words, gradient descent is actually taking the partial derivative of loss function with respect to weights for updating the appropriate weights. So let's see how can we partial derivate the loss and update the weights. So guys, let's say here we have to calculate W7 new, then this will be equal to W7 minus learning rate multiplied by derivative of loss function with respect to weight W7. So whatever derivative value we will get, we multiply it with learning rate, which will be very small value. And we are taking this value as small so that it goes till the global minima for converging mode. And then subtract this from the actual weight W7. Once we will calculate the derivative of loss function, we have to update all weights by the same mean, including W1, W2, W3 and so on. Once we update each weights, then again we forward propagate the network till the output layer, and same process will go ahead. It will go for a certain number of epochs unless and until this loss value has completely reduced. And once this loss value reduced, you will see that actual y value and predicted y hat value will match. So guys, let's understand all this with an example. Let's assume a very simple neural network with just one input layer, one hidden layer, one output layer and one weight connecting to each of them. So it's obvious to see that y would be x multiplied by weight w1. So if we change w1 a little bit by just taking derivative of y with respect to w1, that we get x as a slope. So if I change w1 by a little bit, my y will get changed by x times the size of that adjustment. Similarly for output, O is y times weight w2, and when we calculate derivative of output with respect to y, it's just weight w2. As this network is so simple, we can calculate from input end to output end. So here, output would be x times weight w1 multiplied by weight w2. Now if we calculate how much will the error change if I change w1, we just take the derivative of that with respect to w1 and gets x times w2. So you can see that this term is actually the product of our first derivative, that is derivative of y with respect to w1 times the derivative of next step, that is derivative of output with respect to y multiplied together, which is known as chaining. Guys, just to give you an intuition, we have to back propagate activation function as well. As we have considered sigmoid function, let's understand this. Let's say x is my neuron and s is my activation function. Now if I want to back propagate this, then my s will be 1 over 1 plus e to the power minus x, and let's write it as sigmoid of x for simple calculation. So now derivative of s with respect to x would be sigmoid of x times 1 minus sigmoid of x. Guys, there are a lot of problem happens in neural network, that is vanishing gradient and exploding gradient, which I will be discussing in upcoming sessions. So guys, this is all about how can we train a neural network with the help of forward and back propagation, cost function and optimizers. Hope you guys understand each segment of this video. Stay connected for learning more interesting facts and tech stacks. Thank you guys for your time. Do like, share and subscribe. Hit the bell icon to get the latest updates. Happy learning and stay safe.